In the diagram, ABC triangle has measures 60, 5x, and 3x. What is the value of x? The sum of the angles of a triangle add up to 180, and therefore 60 plus 5x plus 3x is 180 degrees. Therefore 8x is equal to 120, and therefore x is equal to 15 degrees. A farm has 500 animals, each of which is one of three types of goat, a cow, or a chicken. The number of goats is 2 times the number of cows. If 10% of the animals on the farm are chickens, how many of the animals are cows? We've got goats, we've got cows, and we've got chickens. So 2CO is basically the number of goats, 2 times the number of cows, as the question states. And then the cows I don't know, and the chicken they're saying is 50. It's 10% of 500, so it's 50. So that's it. So the total 2CO, 2 cow times cow plus 50 is the total, which I believe is 500, right? Yeah. So that means that 450 would be equal to 3 times the number of cows, and then the number of cows therefore is 150. And that is what they were asking for. In the diagram, BD is perpendicular to BC and to AD. If AB is 52, BC is 21, and AD is 48, what is the length of DC? So this is Pythagoras again. BD squared is plus 48 squared is equal to 52 squared. And when you solve for this, you get BD equal to 20. So put 20 over there. And then they want DC. So DC squared is 21 squared plus 20 squared, using Pythagoras once more. And when you solve for this, you get DC equal to 29. The positive integers 1 to 576 are written in 24 by 24 grid, so that the first row contains the numbers 1 to 24. Second row contains the numbers 25 to 28. And so on. An 8 by 8 square is drawn around 64 of these numbers. The sum of the numbers in the four corners of the 8 by 8 square is 1646. What is the number in the bottom right corner of this 8 by 8 square? Okay, so somewhere in here, there's some 8 by 8 square that they're concentrating on. Okay, so 8 by 8, huh? So let me just make an 8 by 8, and then we'll talk about it. Okay, so this is 8 by 8, I believe, if I've done this properly. Yeah. So what they're saying is they want you to concentrate on the corners, those guys. And they're saying that those guys, those corners, I don't want to label it because it's so small, but you guys understand. Those corners, if you add them up, it's 1646. And then eventually, they want me to figure out what is the one in the bottom right. So bottom right, I believe, is this one right here. Okay, I think that shouldn't be too hard. Let me just start off. The first one, I will just call n. So this will be n plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. So this one will be n plus 7. So this is n, and this is n plus 7, the second one. Okay, so now I've got to figure out what are the bottom two. Okay, that's the challenging part. It's not that obvious, actually. Oh boy. Okay, so how do I figure out what is these two guys down here? Let me think about this. Let me go back here, and maybe it'll help me if I look at the top one more time. 48, so it'd be 49, 50, ... all the way till it's 8 wide, right? So it'd be 49, 50, 51, 52, 53, 54, 55, 56. Is that right? For some reason that doesn't seem right. All right, what am I doing? I'm thinking that this is 8 by 8. This is 24 by 24. Ah, okay, that's why it doesn't seem right. So you got to add 24. So this will be 72 and this will be 71. Ah, I got to be careful here. This is 8 by 8 down here. And this is 24 by 24. Okay. But if you create an 8 by 8, it should behave like something like that. Like it would be something like this. I think if you're jumping rows, you're just going to add 24 each time. Is that right? 24. So I think that's what's going to happen. You're just going to add 24 each time. So this would be n plus 24, this guy right here, and then so on. So I think that's how. So this would be n plus 48. Okay, I got it. I think I figured it out. All right. So this would be n plus 24. I'm just going to write the plus part because I don't have much space. This will be n plus 48, that guy. This guy would be plus 72. This one would be plus 96. I'm running out of space here. This one would be plus 120, another 24. This guy would be plus 144. And then finally this one, the one that we want, would be another 24, so plus 168. So it would basically be n plus 168. And to get this one, that's easy. You just have to add another 7, right? Because it's 1, 2, 3, 4, 5, 6, 7. So that would be n plus 175. Okay. All right, I got it. So now this is very easy now at this point. So this is 4n plus 350, I believe. Yeah. And then that's 1646. So 4n would be 1296, and then n would be 324. But we don't want n, we want this guy. And this guy is represented by n plus 175. So n plus 175 would be 324 plus 175, 499. There you go. So I guess the hard part for me, or for, I guess I'm assuming for other people also, is to kind of figure out how to get this one here. And we did that by adding 24 to each row. There are 5 pairs of integers a, b, with a between 0 and 10 inclusive and b between 0 and 10 inclusive, for which points 1, 1, 4, 5, and ab form a triangle that has an area of 6. What are the 5 pairs? Let's draw a diagram and let's talk about this. So here we go. First, let's draw in those points. So approximately here, that's 1, 1, and then 2, 3, 4, 1. Oh, I'm going to probably need a little bit more space here. So let me make it here, here, and here. So these are the points. So this is 1, 1. This point. That point is 4, 1. 4, 4, 5 is up here. 4, 5. Yeah. And then I made it a right triangle because if from here, this is 1, this is 4, right? So this would be 3 in terms of its length. And this is 1 and this is 5. So this side would be 4. And therefore, if it's a right triangle, the area would just be 1/2 base times height, which is 3 times 4. And then that makes it 6, which is what they want. So what I did was I just kind of made it, I guess, in a way that it works. And this point, therefore, which is 4, 1, is one of those ABs. So one of the values of AB is 4, 1. Now, what are they saying? They're saying that there's 5 pairs. Okay, so I got one of those 5 pairs, and they want to figure out another 4. Okay. So I think basically these 2 points are fixed, right? Those 2 points are fixed, these ones. So what you can do is create triangles that have the same height and base, and that would do the trick. So, for example, if you were to sort of make parallel lines to this guy, like that, and let me just see here. So, for example, if you put the point here, and that, if you made that kind of triangle, it would have the same height and the same base. The height is still 4, and the base, we want to make it 3. And if the base is 3, then that means this point right here would be 7, 5. So another pair is 7, 5. And then similarly, if you stretched the triangle to up here, let's say, and then you again made that triangle, it would again have the same height and length, base and height. So the base would still be 3 and the height would still be 4. So this point would have to be moving over you have to go up 4 and go over 3. So keeping that, if you're going up 4, then it would be 9, and then if you went over 3 it would be 10. So 10, 9 is another one. And in a very similar way, if you go up 4 from here and go across 3 from there, like that, then that would be, let's see here, well, you'd still be 4, but then that would be 9, and that would also create a triangle that has, with these, it would have the same base and the same height. So that's 4, 9. And then finally, the last one I think would just be the complement right here. Yeah, this point would be, the other point, and that's 1, 5. So there you go. Those are the ones. 1, 5, 4, 9, the original one that I found, 4, 1, 7, 5, and 10, 9. Because all of these make triangles that have the same base and the same height, and that base and height are 3 and 4. There are 20 chairs arranged in a circle. There are n people sitting in n different chairs. There are n people stand. These n people stand, move k chairs clockwise, and then sit again. After this happens, exactly the same set of chairs is occupied. For example, if the 2nd, 4th, 7th, 9th, 12th, 14th, 17th, and 19th chairs are occupied to begin with, then exactly the same set of n equals 8 chairs is occupied after each person moves k equals 15 chairs clockwise. For how many pairs nk with n between 1 and 20 and k between 1 and 20 is this possible? All right, so first let's try to understand this question. Well, let's just understand it, or try to understand it, with the example that they gave me. So let's say you have, it's a table and they're sitting all around the table, right? So there's 20 chairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So they're saying the second, so let's say if this is the first, this is the second, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, 19. Those are occupied. And then they're saying, and so there's n chairs occupied, right? 1, 2, 3, 4, 5, 6, 7, 8. So that's why n is 8. And then they're saying this k, what is k representing? K is representing the number of chairs that they move. So k in this case is 15. So what that means is that the person moves 15 chairs. So the person, for example, here, who is in the second chair, if he moves 15 chairs, he will end up in seat 17. Got it? The person in 4 will end up in 19. The person in 7 will end up in 2, right? Because he's going around. And so on. 9 will end up in chair 4. 12 will end up in chair 7. 14 will end up in chair 9. 17 will end up in chair 12. And finally, the 19 chair will end up in chair 14. Now, why is this significant? Because if you notice, these guys are the exact same as these guys. It's the same 8 numbers. It's a different order, of course. And that's what this question is all about. That if you have these n people and they move k chairs clockwise, after this happens, exactly the same set of chairs is occupied. So that's basically the, I hope, explanation of the question with a little bit more detail. Now what they're saying is that, okay, this happened when nk was 815, as we have shown. They're saying for how many more such nks does this happen? And these are the parameters where n is between 1 and 20, and k is between 1 and 20 also. All right, well, let's see. For how many, let me think about this. So, for the number of values of nk, is that what they're asking? Yeah, how many pairs? Okay, got it. All right, so let's figure this out. This is going to probably involve a chart, most likely. So we got k, we've got the number of n values, the number of values of n, I think the better way of writing it, the number of values of n, and then we're going to we'll see if I can list them all, list the values of n. And then at the very end, I guess we have to add them all up. Yeah. And the k is between 1 and 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I think because of the cyclical nature of this circle, that the second half will be exactly the same as the first half. Like what I mean is that whatever I get for k equals 1 will be the exact same for k equals probably one of these at the very end. I can't predict exactly, but my guess is like either 20 or 19. So let me just see what I can do here, and off we go. All right, and then at the end, of course, we'll just add up the total, and the total is going to be this box right here. Okay, so let's start off with a few of these. I think the easiest one is if they're all occupied, and that's when n equals 20. The k equals 20. K equals 20. That's going to give us our desired result if for any value of n, if n equals 1, 2, all the way till 20. Because think about it, k equals 20 means that it's going back to the same position. So if you're at 3, you move 20, you're going to go back to 3. So no matter how many seats are occupied, k equals 20 will always result in the same. So there's 20 values of n, and those 20 values of n I've listed there. Now, let me go back to the start because I think that's better. If k equals 1, the only way that's going to work is if all chairs are full. So n can only be 20. So there's only one value there. So for example, if all the chairs are full, and then each person moved once, all the chairs, the same chairs would be full. And that only happens when n equals 20. So that's only one. So when k equals 2, then I think that will only happen when n is either 10 or 20. And then that way, when n equals 20, obviously, but then when n equals 10, you can put it in like every other one, and then when you move 2, it'll end up in the same. So there's 2 values there. So you just got to painstakingly go through this, unfortunately. When n equals 3, it only works when it's 20. So unfortunately, there's only one value there. When n equals 4, that'll work when n is 5, 10, 15, or 20. So there's 4 values there. When k, sorry, I should be saying when k equals 5, it works when n is 4, 8, 12, 16, and 20. So you got 5 values there. When k is 6, it only works with 10 and 20. So they got 2. When k is 7, only works when n is 20. So you got 1 value there. When k is 8, that is going to have 4 values, very similar to that one. When k is 9, we have only 1 value, and that's n equals 20. When k is 10, that will work when you have even values of n. So there's going to be a whole bunch of those, 10 of those. And then for 11, there's only one scenario. And then for these guys, for k equals 12, 13, 14, 15, all the way till 19, it's the same as I had previously thought as k equals 8, 7, 6, 5, all the way to 1. So if we were to fill these in, it would be the same as the top, but in the reverse order. So it would be 1, 2, 1, 2, 1, 4, 5, 2, 1. And 4. So let's add this up. We got 3, 4, 8, 13, 15, 16, 20, 21, 31, 32, 37, 39, 44, 48, 50, 51, 52, 72. There we go. 72 is the answer.